before, welcome everybody from all parts of the world. Good morning, afternoon, evening, wherever it is in your time zone. Thank you for joining us. It's a pleasure again to be hosting this webinar. I'd just like to mention that this webinar is about paving the way to traffic safety and analytics, and we'll be detecting near misses for a proactive approach. Given that, we invited a very special guest, which is Ariel Godwin. He'll be introducing himself after. I'll be giving him over to the presentation. He has a very interesting presentation into this area from GTS, and he'll be sharing his experience of using the GoodVision platform in conjunction with the projects that he's working on. So maybe, Ariel, I hand this over to you and I'll let you introduce yourself, and it's all yours.
Thank you very much, Chris. So a quick overview of GTS. We're a transportation engineering, planning, and technology solutions firm. Our central office is in Los Angeles, and we've done projects across the United States, mainly on the West Coast, and many projects internationally as well, mostly in the Middle East. We provide a range of services from traffic engineering and transportation planning to smart city infrastructure design, bicycle and pedestrian planning and design, and parking optimization, among many others. Our company was originally created with the vision of strengthening the link between government and Silicon Valley, integrating the newest and most effective technology into transportation. And we operate around three basic pillars, really. We want to save lives because improving transportation safety is so important to us. We want to save time because we have an emphasis on improving the efficiency of traffic flow. And we want to save space because we're interested in multimodal solutions that can accommodate all modes of travel without necessarily increasing the overall road width or capacity. So to give a brief overview of the project that is the subject at hand today, it relates to analysis of traffic interactions at an intersection. This is in a suburb of Los Angeles, and it's the intersection of a fairly well-traveled major arterial road, average daily traffic around 30,000. And the cross streets are two local streets. They're classified as local streets, but they, at the neighborhood level, they're kind of the, you might say, the collectors, the feeders anyway, that bring the traffic out of fairly extensive local neighborhoods onto the arterial. So the side streets get a fair amount of traffic, not enough to bump them up to arterials, but enough to be significant. So it's a signalized intersection, and the collision history is shown here. Basically, the city kept getting requests from residents for some kind of safety improvements, mostly a protected left turn signal, because there was this perception, a growing perception, that there were near misses involving left turns. Now, the MUTCD, for those of you not familiar, that's the Manual of Uniform Traffic Control Devices, which is the standard that is followed in instances like this. The MUTCD guidance has certain standards for when a protected left turn phase should be implemented. And that includes various things that the intersection didn't quite meet the threshold for, although it was close. So, for example, 5 or more left turn collisions for a particular left turn movement during a recent 12-month period. Well, that's the trigger in the MUTCD. As you can see in the list above, 4 collisions in one year, 3 collisions in another year. So our intersection was very close, but it wasn't quite there. And then there are various other standards, but essentially our intersection did not meet the triggers, and yet residents kept complaining of safety concerns, and we felt that something had to be done before anything worse happened. We did a range of analyses on the intersection. We did site distance analysis and found that although it's true if you stop behind the stop bar, your view may be somewhat obstructed, but if you just pull forward a little bit after stopping, essentially you can see sufficiently to meet the sight distance standards for the given speeds. We looked at the intersection alignment, and it was true that that due to the alignment of the medians, there may be some sight problems when there are big vehicles waiting to turn left, and it may or may not have contributed to some collisions or near misses, but several other factors are at play, including the speed, and so correcting the left turn lane alignment would not be any kind of silver bullet to solve the safety problems here. So we ended up recommending to the city an incremental approach where we said begin by immediately start active monitoring of operations at the intersection to identify near misses and install a couple of immediate safety measures that are low cost and easy to install: pavement markings, yellow reflective backplates. And then longer term, think in terms of realigning the intersection and correcting the offset of the concrete medians and installing a protected left turn phase. Why not immediately install a protected left turn phase? Because the city has many competing demands. It would require significant design work. It would cost about $500,000 because of the nature of this intersection. There would be utility work involved, a lot of coordination. It would take 1 to 2 years. It's not the kind of intersection where a left arrow can be implemented simply, easily, or cheaply. So, and the city has to prioritize where it spends its money and make sure that that's accountable. So the city proceeded with the first step, which was the active monitoring. And so we did the active monitoring, and this is where GoodVision's really, truly amazing software interface came into play and made things a lot easier for us, made us able to produce very interesting results, and saved us a lot of time. This is the GoodVision interface where video footage of the intersection is analyzed. We gathered 100 hours of video footage. And here, the green lines here are an enormous amount of vehicle tracks, each line representing the track of one vehicle that went through. And I believe we have around 45,000 on the major routes, so that there's a lot of data here. So this interface enables you to very easily create a track. That's the white bars that I laid down there. And then you can generate a data set among many other capabilities the software has. You can generate a data set that shows the exact time at which the vehicle crossed that white virtual bar that I drew. The video frame rate, I believe, was 24 frames per second. And so we were wanting to have an accuracy of down to 1 second. So this was definitely sufficient for that. Incidentally, the yellow lines here are pedestrians, so that could be analyzed as well for a future project. The software breaks things up by travel mode. So this, in any case, allowed us to identify near misses by quantifying the gap between when a vehicle comes from one movement and the time distance between that and a vehicle from another movement. So we were able to look at exactly what was happening. Just by filtering the spreadsheet, we were able to identify when near misses happened and see exactly, go to that point in the footage, scroll along, look at the corresponding minute and second, and look at exactly what happened. And we did this for 4 different turning movements. We looked at left turns because people had talked about left turns, and we looked at right turns on red because some people had come out vocally in both directions, as in this intersection should not have right turns on red, and this intersection should have right turns on red. So we found we were able to see what was going on with right turns on red, and you can see the kind of near miss that's happening. It may not look as dramatic here, and we didn't catch any collisions, but when traffic is traveling at 45, 50 miles per hour and there's only 1 second between vehicles, it really is a near miss. So we can see that a little better in the next slide, where you'll see in this direction this vehicle swerves to avoid the other line at really the last split second. So we were able to identify a lot of events like that, look at what was going on, and quantify the number of near misses less than a second, near misses of 1 second, near misses of 2 seconds. And as you can see here, we had an enormous sample size with many tens of thousands for each movement. And so we were really able to produce a statistically valid study. In terms of the near miss time, the perception reaction time, a typical driver's reaction time to apply the brakes, there's been a lot of research on this, and the ballpark consensus roughly is that it takes about 1.5 seconds to react and apply the brakes on average. But beyond that, when you're going at 45 miles per hour, which is the prevailing speed on this road, and that's about 72 kilometers per hour, you need about 140 feet to stop, so about 40 meters. And then at that speed, your vehicle is traveling 20 meters per second. So a 1 second gap leaves very little room for error. And we do want to have plenty of room for error in our transportation systems, which involve such high speeds and such considerable vehicle weights. And of course, it's important to note that on this road, the prevailing speed was 45 miles per hour, but some through vehicles were passing through faster at higher speeds, 55 or so. And of course, some drivers are going to have slower reaction times than the average 1.5 seconds above. So this really allowed us to recommend a proactive approach where instead of waiting for the threshold number of collisions to happen, we recommend to the city to solve safety problems proactively before more people become statistics, as it were. So we recommended, based on the number of near misses observed, a protected left turn phase was recommended, and based on the number of near misses for those for the relevant turning movements, prohibition of right turns on red was recommended for the minor street approaches. So this was an overview of our study, and again, the GoodVision software helped us tremendously. Being able to use that AI-driven interface to get through the enormous number of observations made all the difference. And I'd be happy to answer any questions about this project, and my contact info and Chris's contact info as well as on this slide if anyone would like to get in touch.
Yeah, thank you, Ariel. I mean, I have some questions myself as well regarding the presentation, which is a real nice insight to see from the user points on using our platforms and getting the information that you need. The question I probably have for you is when using this our platform, from traditionally how you were collecting and looking at this information, where has it really kind of helped you in the areas? It saved you quite a lot of time? Is it able to back up things with your clients? Like, where's kind of like the critical areas it's really assisted you more than before, or how you were doing things before?
I think the really critical areas are, well, one thing is sample size. Anyone familiar with statistics knows that a bigger sample size is better because you're going to be observing more events and get a more statistically valid result. And so just in terms of time resources, the traditional method would have been to put up a camera and then have someone, and maybe even it's an intern with a cheap hourly rate, but some human being look through all the footage and identify near misses. So I think it wouldn't have been feasible to work through 100 hours of footage, really. It might not have been realistic at that rate. The other thing is the human error factor. So if someone has to go through 100 hours of footage and identify near misses, they're going to make mistakes, maybe. They're going to miss some events. And so, so using this AI machine learning model to do that, both save time and resources for us and our client, and allowed us to deliver results much sooner, of course, and in addition, improved the level of accuracy.
Yeah, I'm not sure. I mean, it's giving you a lot more confidence in what you're delivering to the end clients, especially when they're asking you, then how do you how have you qualified that? Show me. And with the platform, that's exactly what you can do. You can show them exactly the points, video areas, and the snapshots. So that's brilliant.
Exactly. Yeah, I think it's a great example of how human and machine can work together in a sense, because it took a human to think about this project, and it took a meeting of many humans to get together and say, what are we going to do about this intersection? What's our approach going to be? And then the machine learning comes in for the actual data processing. It was a very good collaboration.
Exactly. Yeah, I think you've helped the attendees understand, and whoever's going to watch the video, that AI is not taking your jobs. It's a tool to assist you and help you with with your day-to-day work, and I think saving you time. And also taking these kind of manual, and also, as you're saying, not possible tasks for a human being in a sense. To do in such a short time. So now we're kind of reducing that, trusting the system to give you the results and showing you the capabilities. So yeah, it's great to see you utilising that. I know that we'll have more kind of projects and work with you because there's lots of things coming. So we'll definitely be speaking further and how to even present, even automating your PET and the time to collisions, and maybe take that away as well to get kind of an automation feel. So there's lots to come. As always with the GoodVision product, we're constantly adding these new capabilities, but it's all possible with people like Ariel, and you who have joined as well to the webinar. A lot of you are clients, or you're new to GoodVision. Or your competitors as well. We like to see the competitors come into my webinars to see what's going on, and it's a healthy environment to look at things, because I also think that computer vision, or how do you say, video analytics, I would say, really, is a part of the tool sets that people will be using. There's lots of ways. We have LiDAR, we have the other ways of using TomTom data, V2X, all these types of data points. And I think they're all vital in certain areas, to give more, how do you say, depth and breadth of the data. And as you mentioned, for kind of analytics, that's the bigger pool of data that you can get is going to give you that capability to quantify your information. So I'm really happy that we've been able to help you, and also give you that information, and as you said, to protect lives and reduce these statistics, and make sure we can bring something to these smart city initiatives. I don't know if we've got a few questions, I think, coming in. I don't know if you can see them as well, Ariel, but there's 3 now popping in. So let's have a look. So we've got one here. I think this might be directed at GoodVision, but could LiDAR be used in place of cameras? Is it more precise than customers for intersection monitoring? I don't know, what's your thoughts on, have you tried to use LiDAR, Ariel, in any of your projects? Is there any kind of pluses and minuses with that from your side?
We haven't tried to use LiDAR yet, and but I think there's enormous potential just when we think about the electromagnetic spectrum, right? The visible light doesn't necessarily have to be, we don't have to be confined to the visible light spectrum for the data that we gather. We can look at other parts of the spectrum, because what matters is the camera gathers the data, the computer processes the data, you get the results, and that informs your recommendations. Of course, it's helpful when you can see things. Other than that, I would imagine there's enormous potential in LiDAR, yes. And I don't know for a fact whether it's more precise than cameras, but I think that's definitely something to investigate.
Yeah, I think with these emerging technologies and so on, it's something to also consider. Currently, GoodVision itself doesn't process LiDAR data. We're purely based on visual, motion. So we rely on a video or some format that you can put into the system. Anyone that would like to trial the system, you can take a free trial. You can upload your video formats into our system. If you have them today, you can do it after the webinar, and you can process the footage. If you speak with our support, they'll be able to give you some access and also some means to process some hours, so you can see what what kind of data you're working with, as Ariel has it's shown you here from some of the screenshots of what you can see. There's lots of things that you can gather from this data. I think it's very rich. So that's why it's always good to have a little conversation just to see what you're interested in, so we can show you exactly how to use the system. Maybe that's one point as well, Ariel, I'd like to always cover, because I think not only the platform is very important with the feature sets, but the support elements. How was your experience with the support from GoodVision? You can be honest, okay?
I think the interface was very intuitive and very easy to learn. And I saw it had a lot of capabilities that I didn't actually use for this study. So it seemed like there's a lot more there that I barely scraped the surface. The only time I had issues was with video compatibility. And that's down to formatting. So my videos were in a format where the file extension was 264, I think, and I had to convert them, but that's life. Sometimes you have to convert things. So yeah, all in all, an excellent interface, very, very intuitive, very easy to get the data from it.
Good. Yeah. That's the thing. There's so many formats out there, and obviously, if you've got some issues with any formats, we've got the desktop application that can also help convert your videos, and also we have our support channel that you're able to speak with and get some support as well if you need any help. We will always have someone available to give you some support and some tips. If it helps to correct it, we will do. We've got a few other questions here. Got one from Martin. How could GoodVision audit / QA the accuracy? Good question. Well, I mean, go ahead.
Yeah, I can speak to how GTS audited and QA'd, and I ended up looking at every near miss generated by the GoodVision software. Essentially, and that was a very easy process because you just find the point in the video with the minutes and the seconds and look at, essentially you get a spreadsheet from the GoodVision software and you sort and filter your columns to see when the 2-second near misses were, the 1-second near misses, and then you can just go to the point in the video, see what happened. And that was a method of QA. And I did at that point find some events that I didn't think really qualified as near misses. The software maybe flagged more events than I ultimately made it into the table, the statistical table. So that's one way. I mean, it gives you an easy ability to find the points in the video to look at, and you can just QA it visually. I'll let you speak to things on GoodVision's end.
Yeah, I mean, well, exactly as you're saying, you can qualify it from the actual physical video. So if we're saying we've done a detection, you can check it and see. Of course, there is false positives as well. There's false detections. There's no 100% system on the market, although there's lots of people that will say they have, but I doubt, and I question that. We're working with a range of data, so we're realistic in the data from about 95 to 98%. I would say, from my point of view, and when I work with clients, that's the accuracy level. It's usually a lot of factors. It's not kind of a straight cut question, because there could be many factors: the quality of the video, position of the camera, and so on. So the better the quality, the better the position, the better the percentage of the results can turn out. As well, there's weather factors, there's objects that could be potentially in front of cameras. So we always aim and we always work towards a very high percentage, the best that we can get from the data provided. GoodVision can always advise and give you some advice and tips on. We would suggest a different placement of the camera. maybe adjusting the settings just to enable that ability with the accuracy. We've got another question here. What's your video resolution? Do you think better resolution will give you more accurate results?
And I've been looking at my video files trying to find the resolution, and it's not showing me the exact resolution. I think it's something like 1500 by 1500 pixels, but I can't recall exactly. And yes, I think better resolution would give more accurate results, and the only trade-off would be processing time. It was easy and fast to upload the large video files to the vault, though. I will say, good part of that's on my end. I have good internet upload speeds, but also the GoodVision vault had good upload receiving time. So that worked well for large files.
Yeah, and that's the only kind of bottleneck sometimes. I mean, our system, from once we have the footage uploaded and it's on the GoodVision side, we process it using AWS servers. So I think it can be processed between 1 to 2 hours, no matter the video length. It can be processed for fixed cameras. I think it's more the uploading is where the bottlenecks can be sometimes. Because as you said, Ariel, if you've got good connection, no problem with uploading. I mean, I have a fixed upload speed, which is about 50 meg, I think. So I think it can be very varied with the upload speeds. But if you've got a good business connection, it's not too much of a pain. And anyway, if you're usually doing these kind of studies and sending them externally, you have to send the video files or put them into Dropbox or put them into some cloud platform for someone to download or look at or process. So that's also an added journey of a day or two just to get that done. But with the system, once it goes in directly, also with the GoodVision platform, you are able to link any of your, well, I say any, you're able to link your cloud storage providers. So at the minute we have like Dropbox, we have G Drive. Hopefully soon we'll have OneDrive as well connected. So it is possible to directly link the cloud storage devices and simply just take the footage and be processed into the system. We've got another question here, which is from which safety surrogate measures can you automatically compute / estimate?
Right.
From what you played with.
Other than this study, so one other type of study and variable that comes to mind is definitely a gap study, and that's a study where the gaps between vehicles on a main road are measured in terms of what size of gap a driver trying to enter the main road will accept. So if you're trying to get onto the arterial and turn left or right onto the busy road, you're waiting at the stop sign. Will you wait for a gap of 6 seconds between vehicles, or 10 seconds, or 3 seconds? And this helps to determine various things that may need to be improved in terms of traffic flow and safety. That's one application that I could definitely see us using right away, and we have in fact done that the old-fashioned manual way in past. So we're thrilled to have the option of this software now. And I'm sure there are many other applications. I think we'll have to see what new studies are down the line.
Yeah. I mean, there's quite a breadth of features platform can do, from very simplistic, TMC reports and classifying movements, categories of cars, trucks, cyclists. There's lots of other things with time gaps and so on. It's quite in depth. I'd encourage everyone here to go for a trial. It's free. You can process your own footage. You can play with the system yourself. You can see the results instantly. Of course, as always, as I keep saying, please utilize our support team and our specialists, because they'll walk you through the platforms, they'll give you the guidance, they'll show you what's possible. And also, as the biggest thing with GoodVision is we listen to our community, we're listening to users, we're gathering information. that is useful for the industry, not only just single users. There's normally one thing that is useful is normally useful for everyone else, or helps to optimize time. So we're always open to hear suggestions of something that could support the community in using our platform, or the industry that requires these movements and measurements. A lot of these features are kind of client-based and industry-based features that have been designed. Lots of them are coming from you guys, so please keep speaking with us, and we'll do our best to make sure we provide these outputs and what's coming in the future. We've got a question here. Is the solution? Is this solution with ANPR cameras, automated number plate cameras? So any kind of camera system works with. So if your ANPR camera can do a recording, yes, but I know most ANPR cameras are still image based. So we don't work on still images. We work on a video footage. So if your ANPR camera is capable of starting, or say recording videos, yes. If it's not, then unfortunately not. We've got some clients using or utilizing their current infrastructure. So if you do have infrastructure of cameras, it's not necessarily meaning you've got to replace everything with hardware. Like everything, your cameras will need updating, because you can't have them from the 90s and whatever with the pixel rates that were then. All the devices are getting more clarity, they're getting more smarter. There's even cameras now with AI inside the camera. So everything changes and will need updating. So if you've got some cameras already installed, as I said, we have a free trial. You can upload a sample of that footage. You can see how it performs. We can give you some kind of feedback and recommendations. Another question, I think it's the last one we've got. Question, GoodVision, what other case studies have you seen your tool being used for? Good question. We have quite a lot of case studies. On our website, we've got quite a few. We're seeing them on private toll roads. We're seeing them on smart city initiatives, parking for taxis, highways. There's a multiple plethora of use cases, from even shopping malls to retail with marketing on retail signs, how many people are viewing or in this area, potential footfall. So there's lots of kind of case studies. We're kind of really focusing on the traffic industry, but our system is not kind of, it's not kind of confined to like an intersection. It's not confined to a highway. As long as these objects are present, so you can have cars in a field and the system will still detect and show you where they're going. It's really based on the objects. So wherever these objects are, we detect them. We'll be able to give you the tracing of where they're going and how they're moving. We've had projects globally, so we are global. We have projects in Africa, we have projects in Latin America, North America, Asia Pacific. And it's very interesting when we work with worldwide. You see lots of different characteristics with all the regions on the driving habits and pedestrian habits. So in Europe, we're very uniform with pedestrians following the pedestrian signs and the crossings. But if we take an example, we did a project in Ethiopia, and pedestrians are everywhere. They go where they want. It seems like they rule the kind of highways and roads. So there's all different kind of insights to give you as a traffic engineer, ways of helping to make the intersections better, motorways, toll roads, improving and giving you that insight. And as I think that the most important thing also to mention is GoodVision is not here to tell you what the solution is. We're really here to present you the data for experts like yourselves to and like Ariel to make the decisions or informed decisions with your expertise to the the people that you're working with. So that's what we want to complement. We want to complement collecting this data, giving it to you as quickly and as accurate as possible, and also as easy as possible. We say, like, in the technology is growing, but we're still sitting out doing manual counts or video counts with clickers. So I think we need to just kind of look at the new ways and not be too. I know change is difficult and people don't like, we like the old traditional way. That's fine. So some things of the old way work the best, but I think also there's new methods and new ways that can really help drive and give us a really better view to data. So that was the last question. I don't know if you've got anything else you want to address or you'd like to mention, but as Ariel mentioned, we've got the contact information here. If anyone has any further questions or would like to have a trial or get in contact with Ariel, our contact details are there. Please do, and we'd like to speak to everyone further. You'll all receive the email with the video, so you'll be able to play this back. And yeah, it was a pleasure to host you, Ariel, and it was brilliant to see this report of how you're using the system. I'm sure everyone will hear and see a case study soon. So I think it's really great to see this, and thanks for your participation in this.
Thank you very much, Chris, and thanks also to Lana at GoodVision for helping me put this together. Thank you very much for the opportunity. It's been a real pleasure collaborating with you guys, and I look forward to more in the future.
Brilliant. Right then, so thank you everyone for your attendance. As I said, you will have a follow-up email. I'm sure we'll be in touch with you all as well to see how everyone received the webinar and the questions. And yeah, if you've got any kind of similar projects that you want to test out with GoodVision, please do. The trial is free, as I mentioned, and we can give you some support in how to use the system and give you walkthroughs. So thank you everybody for joining, and enjoy your day.